Hello everyone, welcome to episode number 24 of this Amiga programming series, programming the Amiga in 68000. Thanks to Fabio Ciucci for his book. Basically, we are doing this series. We have arrived in chapter 7. We are doing collision detection. First of all, I'd like to thank again Fabio Ciucci for letting me streaming his book. Without his permission, this would not have been possible. We are streaming, as I said, how to program the Amiga in 68000, doing the hardware way, okay, not the OS way. Okay, so let's start with the book where we left. Okay, so we finished here where the gray part is, but I'm going to go a little bit backwards, okay, where we said, okay, where we were here, and we said if we have a background, okay, and we want to check for color number 13, okay, so collision with color number 13, okay, then you enter the number in the lower 5 bits, okay. If we have a 4-bit plain screen, that is 16 colors, and you enable all the bit planes, that is to show you here in the first bits 0 to 5 is where you specify the color, and 6 to 11 is where you specify the bit planes with which you want collision detection to happen. Now, do not confuse this register with BPL con, okay, BPL con, register 100. It's there so that you tell the Amiga how many bit planes you want to enable. This is you telling the Amiga which are the bit planes where you want collision detection to happen. There are different things, okay? So don't confuse them. As you can see, we are checking for color number 13, this 1101, that is color number 13, okay? And these are the bit planes that we have enabled or we are checking against, okay? So now things get complicated when we need to check for collisions and we have not a normal screen but a dual playfield screen. You can have collision detection as we saw with dual playfield. How does this work? I'm going to remind you what I showed you last week. Okay, so first of all, remember the registers in CLX con, okay, the 0 to 5, okay, how we specify a color. So that is 6 registers, okay, 6 bits, okay. So let's go to the tablet. Okay, so we have, as you can see here, I need to click on it so that you can see the mouse. As you can see here, we have the bits 0 to 5. Okay, so we get 6 bits. Okay, we have this value here, what he put in the which is on the book. In a minute you'll see it again. Okay, just to show it to you quickly, just to remind you, let's switch to, and it is where the gray part is, you know, the 11101, the last 6 bits. Okay, just to show you that. Let's go to the whiteboard again. So we have these numbers, okay, but that number is divided into 2. Okay, so bit 0 is for playfield 2, okay, bit 1 is for playfield 1, and it continues like this. So playfield 2 gets 0 1 0. Okay, so playfield, you can see the colors, okay, black and green. So playfield 2 gets 0 1 0 and playfield 1 gets 1 1 1. That means that playfield 1 has got a collision detection with color number 7, while playfield 2 has got a collision detection with color number 2. Here I put another example, the orange and the magenta. So the magenta is 0 0 1. So 0 0 1 is 4 and the orange is 101. Of course I have to put that, which is 5. So we have a collision detection with color number 5. Now that you know how the last 6 bits are divided, let's return back to the book. So here we are saying that playfield 1, okay, has got 1 1 and 1, so that is the 7, and playfield 2 has got 1, okay, which is the 0, okay, has got this one, the 1, and then that one, okay, and we have all bit planes enabled. So this indicates also that all bit planes are included for collision. So we have included all bit planes there, okay. That means that we have 7, the 111, okay, which is 7, and the 2 0 1 0. Remember, in dual playfield mode you can have only 3-bit planes. So a playfield is made of 3-bit planes. Remember, a playfield is a group of bit planes. So because of that, we have all 6-bit planes enabled. Now here's an important note, and it is in red. Please note that the enabled bit in CLX dot, okay, is different for playfield 1 and 2. So what he's referring to here. So if we go back to the Amiga hardware manual, remember this diagram is also on the book, it's just that I prefer switching here because it's easier. What he's referring to is this bit here, okay? When we want to do collision detection between two playfields, okay, the odd and the even playfields, then we check for collision detection on bit 0, okay? That's what he means. As you can see in the table, a collision of sprite 0, this I will show you in a minute, a collision of sprite 0 with playfield 1 is bit 1. So again, hardware manual, remember this diagram, as I said, is further up in the book, but if I scroll the book each time I will get lost, so I'm using the hardware manual to look at the table. So if we want to detect, okay, sprite 0 against the odd bit planes, we use bit 1. If we want to detect sprite 0 against the even bit planes, okay, we use bit 5. Remember, the playfields are divided by odd and even bit planes. As I said, he's saying that here in this paragraph, a collision of sprite 0 with playfield 2 is bit 5. Okay? It is possible to have a sprite test for collision with more than one color. Okay? So, on the screen, on the lower right hand corner, you are seeing a plane, and when it hits number 3, it detects a collision. So we can specify with which color we collide. However, that is showing only one, but we can have more than one color. Although there are some rules to this, but we can have collision detection with more than one color. You just need to obey the rules. So you cannot just select the color just like that. But you can, so there is some thinking from the graphic side. So if you have a GFX designer and he doesn't know how the Amiga collision detection works and thinks that he can use any color he wants and how he wants, he will have an issue, because you will tell him, okay, you need to change these color indexes, and this is what the collision detection will be with these colors. I'm just going to repeat what he said in this because I stopped in the middle of it. It is possible to have a sprite test for collision with more than one color, okay? So you can test for collision detection more than one. This is possible by a combination of various color bits, which we will talk in a minute. To be honest, I said color bits, but remember, colors are formed by bit planes, so the correct word should be actually bit planes, but I will confuse you if I said bit planes. I'm mentioning it now just to, before it was color bits. Later on, one of the examples which you are seeing in the screen here in top lower right hand corner is showing collision with 1, but you will see collision with 2. Now here is where you have to start obeying the rules for collision detection. For example, consider the number 2 and 21, okay? And you need to have collision detection with color index number 2, whatever that is, and color index number 21, whatever that is. There is no way we can do collision detection with such colors because, first of all, they are too far away. Normally, you need to group them together for collision detection. Okay, I'm not saying it's the rule, but it's something that helps. So if you had to write down the number 2 and 22, actually, did I put it yesterday? Let me see what I did before I switch you onto the tablet. Yeah, okay, I switched to the tablet. So here we have the bits that form the color, or the bit planes if you want to call it. Depends how you see it, because remember, bit planes form colors when they are on top of each other. So we have the number 2 and it is this binary number. We have the number 21 and it is this binary number. Okay, sorry, number 21. Okay, they have nothing in common. Okay, so it's very difficult to create a group for collision detection with such colors. They are too distant. Okay, but if we say we have 22 and 23, you can notice, okay, that the only difference is the first bit, bit 0. The others are the same. Okay, so if these are our bit planes, the ones in green, okay, remember we have 6 bit planes, but because we are using 32 colors, we only need from 1 to 5, okay? And this, the only difference is bit plane 0 or bit plane 1, depends how from where you start, okay? Then we can disable bit plane 1 or bit plane 0 and have enabled the other 4. And if we have these 4 enabled, okay, then it means that any collision, because we have that happens here, any when these are the same, okay, when these bits are the same because of the bit planes, they are the same, hence we're going to get a collision detection, okay, of number 22 and number 23. That's how collision detection is worked out. Now, don't try to work it out in your head. I don't know how many times I tried, and I'll make mistakes. Even yesterday during the stream, it comes natural that you try to do it in your head, but trust me, write it on paper as I did here, okay, on my whiteboard, and it will be visible immediately which one is which bit planes you should have on and off. Let's go back to the book. So as you see in the book, he's using the example of 2 and 21, and he's saying, okay, I know you cannot understand Italian, but he's saying that this is impossible. Okay, cannot find the word, but somewhere here is saying that it is impossible. You see, he's saying that the numbers here are completely different. Okay, I mean, sorry, I am translating from Italian. I know that most of you don't understand Italian, but just to show you what he's saying. However, with number 22 and 23, this is different. You can see 22 and 23, they are very similar. Okay, and because of that, we are able to have collision detection. Okay, so setting up register CLXCon. Remember, CLXCon is the control register for collision detection for sprites. Okay, we are saying, okay, that if we want to have colors, okay, 21, 22 and 23, which has got this common 1011, okay, which is, you can see it here, 1011, okay, then we need to enable these 4 bits, which are bit planes, and the first one is off. Okay, that means whether it's 22 or 23, we do not care. It's a collision detection and we need to detect it. That's what we are telling the Amiga. So you can see here, okay, he is saying that bit plane 1 is 0, okay, and he says y, okay, and then the others, okay, so here he's showing the number, sorry, not the bit planes. Here is showing the numbers, how they are on the bit plane, okay. He's saying that the 2 and 22 and 23 has got these 4 in common, while bit plane 1 can be either 0 or 1. That's what he's saying there. So I do apologize. So we continue further down where he says, because of that, we can have collision detection because of this last bit, which is different. And basically he, let me see if he continues with the example or changes. No, he changes. So as you saw from my notes, that is quite clear what needs to be enabled and disabled for which bit planes we need to do that. Now imagine we have the number 8 and the number 9. Okay, they are here. The difference is the last bit. Okay, so it's possible to have collision detection. Okay, so just to say exactly what's in the book, this technique can be used with several other color combinations. So we can combine these 4 groups of colors for collision detection. This works with colors that their difference normally is 1 bit. I would say it works also with 2 bits, because if you switch to bit planes, but when they are very close, normally it's 1 bit. No, if you want a group of 4 or so, then it will be 2 bits. So the number 8 and 9, as you can see, is the last bit, which is different. So we can disable bit plane 1 or 0, as I said, depends how from where you start counting, and we will obtain collision detection with these 2 colors. However, if we consider 10 and 14, difference is bit 2. Okay, so here we have 10 and 14. Come on. So in here, the difference is also 1 bit. The difference of 1 bit doesn't need to be at the beginning, can be in the middle. Okay, that is what he meant. Normally the difference is of 1 bit, but you can also group let's say, the first 2 bits. If you try to do it larger, you might have problems. But when you keep the number small, let's say that it works perfectly. So we were saying 10 and 14. Notice which bit is different, is the third bit or bit 2. Okay? Therefore, we disable bit plane number 3. There is no, it's not possible. There is, yeah, it is not possible to have numbers far away, distant from each other. They have to be close. I mean, you're seeing 10 and 14. To be honest, 10 and 14 are not far away, but 2 and 20, 21, as we saw earlier, it was difficult. It is difficult. That is what he meant. Okay. So here we have the number 10 and 14. The only bit is the third bit, okay, or bit 2. Okay, so we switch off bit plane number 3. So guys, if you talk about bit planes, normally you start from bit plane 1, not from bit plane 0. Let's normally, I mean, people might argue about this, but yeah. So this is the third bit, okay, which is bit 2. Let's do it like binary. It is bit 2, okay, and here we have bit 2, which is different. So you can see some similarities. No, what we switch off, okay, it's the bit that is not common, what we switch off when there is only one bit plane. Let me check my notes to see if I skipped something in this example. Yeah, notice how, which I already explained, how CLX-con is configured. Remember, we have 2 registers. One is the control register, where you say with what you want collision detection, what type of collision detection you want. And then we have the register that we read, CLX dot, which we read it, and from there we know what type of collision detection happened. So in this example, okay, we have 4 numbers, 1, 3, 5, and 7. Okay, the common numbers between them is bit 0, they are all 1, bit 3, which is at 0, all of them, and bit 4, which is at 0, all of them. Okay, the difference is bit 1 and 2. To have a collision detection enabled for these 4 colors, for all 4 colors, you disable bit plane 2 and 3. I think now you're getting the hang of how to do it. Okay, so when the bits that are different, normally you go and switch off the bit planes. Also, where the bits are different, you switch off the bit planes. I'm not saying it's a rule, but it helps to think about it like that. You can also do this in dual playfield. So we were talking about a screen where we have, let's say, 16 color screen or 32 color screen, and we want collision with particular colors. You can do it also on dual playfield. You specify which color you want to collide with for playfield 1, and you specify which color you want to collide with for playfield 2. You can also specify that you only want to collide with one playfield. That is by enabling the bit planes of just one playfield. So the rules still are the same. Okay, so we're going to see example number 1. Okay, for collision detection. The example, okay, is showing um, the plane that is colliding with color number 3, and when it collides, the box on top says collision. Okay, I think collisione, everybody can understand that it means collision. So actually we can leave it running now, and we can go to the book, but this time we go to the book, not of the theory book, but the examples book. So the first example, okay, we're saying sprite colliding with a color. We have two routines. Give me a second, guys. I forgot to switch something on. Okay, so we have two routines. One is the one in yellow, move sprite, and the other one is check for collision detection. Now, the move sprite, as you can see, is it's a very long code. It's just one line. Sub quick, which means we are subtracting 1 to our plane so that it moves left. Okay, this is the collision detection routine, but trust me, it's not difficult what there is here. Okay, we are just reading the register CLX dot, which is DFFOOE. Okay, we keep a copy of it in register D7. Okay, we test. Okay, here is a test. If we have a collision in bit 1, we do something. If we don't, okay, we go to no collision, which is this one. And no collision means we set the gray color. This, you see, the 555 is gray. Okay, dark gray. If we have a collision, okay, then what we do is put red in the same box as you see here. So we are changing from gray to red in the same box, and we exit our routine. So nothing special. It's 4 or 5 instructions. That is all. So the thing for collision detection is not, the code is never complex if you're using the hardware collision detection. Okay, however, is the logic behind it and the reasoning behind it that can be complex. As you see, we only need to set color number 3 here. Okay, the first 2 bits, which are 1, and we enabled all bit planes. We have an 8-bit plane, so 8 colors maximum on the screen, and we are saying we collide with color number 3 there. That is all. If you do not understand or you have issues, either you ask now or come to Discord. Okay, I am more than happy to help. Okay, so as you can see, we have dual playfield enabled. this bit. Hold on. Yeah, here we're saying not dual playfield. We have 2-bit planes enables, 3-bit planes enables because it's 1 1, so it's 3. Okay. Enabled, so that gives us 8 colors. That's the register BPL con 1. Remember, there's a difference between BPL con 0. There's a difference between register 100. Okay, this is register 100 with register 98. Okay, don't confuse them. One is for collision detection. One is bit planes that we need enabled on the screen to see. You always need to see the bit planes, so you need to use register 100. And here you're seeing color number 3. Okay, the value that it has, it's red, it's E. Okay, so it's bright red. Here is where we are storing the color that is shown, and at the top on the Amiga where it says collision, where it puts the number gray or red. CLX dot is used or tell us which collision happened, and it is used exactly the same as for sprites to sprite collision detection, but different bits are used since we are colliding against bit planes instead, which is color basically. So just to remind you, in the Amiga hardware manual, okay, this is CLX dot, okay, the register CLX dot. We say before, because before we were doing sprite to sprite collision detection, so we were using this part of the register. Now we are using bit planes. So for the when we have not dual playfield, we use the lower part from 1 to 4. Okay, and these sprites tell us which they can collide with the bit planes. So we read these bits basically. Okay, I believe the book wants us, let's see, I thought it had finished, but no. Yeah, here he's just explaining what I just said. We have color number 3, so 1 1, and we are colliding against all bit planes. But since we said only 3, then we will only collide with number 3. Even though we enabled all bit planes for collision detection. Here we're going to try example 7.1. Note this time the collision is with color number 2. So let's go to the Amiga. Okay, note we're going to collide with color number 2. As you see, this is the white color. All we did is change the register to say with what we are colliding. To be fair, okay, even if you do not understand how all this works, if you download the examples and you try the registers, changing the values in the register, it's easy to know which registers, how you need to configure your CLX dot. Okay, you run this example. Okay, it's using 3-bit planes, but you can make it to 4, you can make it 5, you can modify it to have all colors, and you start playing with the combination, so you can see with which collisions this is happening, with which colors you are colliding with. If you want more than one color, you can manipulate this register to know. Okay, so the example is there to help you to modify it, to learn from it, So I encourage you to download the examples and try them out. Probably some of you will be trying them out right now while I'm talking, but anyway, it's still good. Let's go back to the book. In the meantime, I'll leave it running. So now, here he gives us another example. In this case, we disable bitplane 1 and we have bit, I think we are colliding with color number 2 and 3 because we disabled bitplane 1. So here he is counting from 0 for bitplanes. Yeah. So we have both bitplanes enabled. Okay. So we have bitplane 1 and 2 enabled, and we are saying we are interested. Sorry, this is still 2. What is different? The difference is, okay, here we have 3 bits, here we have 2 bits. Okay, we left the same settings. Okay, so we have color number 2, but we disabled the last one. We removed the last one. Let's see what will happen. Or anyone can guess what will happen? Let's go on the Amiga. It was obvious, no? We only left a bitplane 1 and 2. So we're going to collide with 2 and 3 because that's the only common values that there are if you had to draw it out. Actually, let me show it to you on the book again. We are not interested in color 0. So although it's enabled, we do not have collision, but we are interested in color number 2, and we have the bitplane enabled for color number 2. However, for color number 3, we disabled it. So because 3 and 2 has got that bit in common, okay, this bit is common to 2 and 3, okay. Of course, we will have the number, the index 2 and 3 as collision detection. You want to see the source? I mean, it's the same thing as, yeah, I can show you the source, no problem. So what we are changing is just the register now. Maybe because the book is shifted now, so it might confuse people. So we have only bit 2 enabled, okay, or bit 1. Let's say bit 1, okay, but we only have these two bit planes enabled. So bit plane 0 is at 0, so we will not collide with it. With 2 we will collide because it's enabled, but with 3 we will collide also, because if you had to put 3, which is 1 and 1, okay, that is how we write 3. It's still the same common bit. Okay, so because we are checking for this bit only, okay, when it is on and off, okay, then we are getting a collision detection. Okay, so that's why, okay, that bit is common, and because they have both number 2 and number 3 has got that same bit enabled, we get a collision detection. I'm going to return back to the book. Same here, you see it shifted. So this time we only have, that is 1, 2, 3, 4, bit plane 1 enabled, okay, and we have bit 1 enabled. So what do you think we will have just with number 1? Do you think it will be only with number 1? I'll answer it for you. It will be with all the odd colors. So with 1, with 3, with 5, and 7. Although we do not have 7 on the screen, but if there was color number 7, we will be having collision detection with color number 7, because we are using a screen of 8 colors. And I'm going to show you that. You see 5, 3, and 1. They all have that bit in common, bit 1 or bit 0. That's why it's colliding with all colors that are odd. So when you're planning your colors and you want sprites to collide with the background, you need to think about this. We can leave it there, I think. So we go back to the book. And I believe we did them all. Actually, give me a second. I'm going to check that we did all examples. I hope there was no RX. Okay, so there isn't one. Okay, perfect. So okay, this is what I'm running the next example because of what I'm going to say. So you should see it, and I'm switching back to the book. Okay, so we are here now. Okay, that was just example 1 that had lots of examples in it. Okay, here we're going to see collision detection between a sprite, okay, and 2 playfields. Okay, as you can see on the screen is showing 3 colors that are for playfield 1 and 3 colors that are for playfield 2. Okay, and it is written there. I think you can all understand playfield 1 and playfield 2, and colore, which means color. So common sense. You can see that the sprite collides when it hits color number 1 in playfield 1 and color number 3 when it is in playfield 2. You can all see that. So, and I'm going to leave it there so you can see that I'm not going to jump to the Amiga because you're already seeing it there. I think it's clear enough. So I'm going to go to the next example, X2, and you can see it says collision sprites in dual playfield. So now, as you see in the example, the collisions are related to dual playfield. So sprites against dual playfield. This is just a precaution. Make all sprites on top of all playfields. Okay, we have 2 playfields, 1 and 2, but we are making sure that all sprites are on top. So when we display them, they become on top of them. We have 2 routines, one to move the sprite and one is for collision detection, like what we had before. Moving the sprite down the screen is the same routine that we've used several times now. Okay, so I'm not going to go into it, but I have explained this and you've seen this routine several times. Nothing changed. It's just we have a sprite at the top of the screen. We are moving it 1 pixel at a time further down the screen. This is the collision detection routine, which is pretty similar to the previous one. We are reading the value, the data register, and we're storing it in the 0. We are testing for bit 1. Okay, so why bit 1? I remind you, bit 1 is sprite 0 with odd bit planes, which is playfield 1. Okay, so that is the first test. If we did not collide, we check for playfield 2. We come here, okay, and we test for bit 5. Why bit 5? It is spread 0 against even bit planes, okay, so we test for bit 5. Same, I'm just going to explain bit 1 when we have a collision detection with um, um, with on the sprite 0 and the odd bit planes. So if we have a collision detection, so if this is true, we have a collision detection, we don't come here, but we continue here. And what does it do? It just puts a red, okay, on the screen, okay, and then we exit, we branch to exit here. That is basically it when it comes to collision detection with playfields for this source. So let me see what other notes I have. as you see here, we have enabled, okay, in BPL con 0, okay, dual playfield, which is bit 10. I believe it's this one. Yeah, because these are shifted, so I cannot really tell. Somehow in the PDF, I think this, because this is bit 9, which you always have to have on, and this is bit 10. Here we're saying that we need that is dual playfield, so we need 6-bit planes, right? If I'm calculating right now, I believe it's these. Anyway, you got the gist. So that is how we enabled dual playfield. Here is the collision detection CLXCon, how we are configuring it, okay, for the sprite against the playfield. Okay, so we have for bit planes against which we are detecting, okay, and remember the colors. So this bit, and this bit. So that is color number 1, and then this bit, and this bit, that is color number 3. So we are detecting collision with, as you see it in the lower right hand corner on the screen. So the sprite is colliding with color number 1 of playfield 1 and color number 3 of playfield 2. That's why it flashes red and green. Let me see if I have something else in the notes that I should mention. I mean, here is where we are storing the color. As you can see, it's register 180, okay, which is color 0, color index 0, and we are putting the either green or red here. So here we are. I just did an example. He just suggested to try one. Okay, so I am going to go to the Amiga. Read the next example, which is what he suggested to try, and you're going to see that it collides with 2 and 2. So in playfield 1, color number 2, and playfield 2, color number 2. I think I can show you, okay, for those that want to see it. I can show you the values that I put in the register. Yeah, you can see this is 0, 1, 0, and 0, 1, 0. So color 2 and color 2 for the playfields. I only had I do apologize, I said it wrongly. I only had not 6-bit planes enabled for collision detection, but I only had 4, but it doesn't matter, because we were only detecting with color number 2. Yeah, if I wanted to have with all colors, I should have these 1. Anyway, I don't think there's another example in relation to this one. No, we do 3. Okay, so I will come to this in a minute. Let's go back to the book. So you see it in the lower right hand corner, this. So we did number 2 and we're going to do number 3. Now, number 3, okay, example number 3. The collision, okay, is between one playfield and another. So there are no sprites involved. So you're going to see when a certain color from one playfield hits another color from another playfield, you get collision detection. Okay? So let's jump to the source. Okay, he's saying what I just said. Collision. When color 3 on playfield 1 hits color 1 on playfield 2, you get a collision detection. This is the routine. This is moving the screen, okay, of playfield 1. Okay, so we're moving it from top to bottom, and then when it hits the bottom, we're bouncing back up. And here we have our collision routine. So moving the screen from top to bottom, we have seen it in chapter 5, I believe. So although I highlighted it in yellow, I'm not going to go into this. We have already covered it. I explained every single bit of it. But what I will go to is, I don't know if I wrote any notes to it. No, in fact, I didn't, because there is nothing to explain. I just highlighted it to make you aware that we have used a routine, that we have used it earlier in the book. And here is our routine for collision detection. Okay, it starts up there, but actually the juice of it is down here. Here we just read the register. Okay, and remember, it is bit 0, okay, that we test collision detection between one playfield and another. Just to remind you, bit 0 tells us even bit planes to odd bit planes, collision detection. Okay, so if we collide, we put red. If we didn't, we put black, you know, the transparent color, which is color 0. We have dual playfield enabled. Okay, it's bit 9, and we have 6-bit planes. Sorry. We have 2-bit planes because we have colors 1, 0 to 3. So 2-bit planes. That is 2. I got confused even before, and now I just said, okay, I need to say it properly. So I was really counting it as I should, because earlier I told you 6 also, but it should be 2-bit planes, because we only have 4 color 1-bit plane, 4 color in the other bit plane. So I do make mistakes. Here is how we configure the register. Okay, we're saying this bit, and this bit. So 1, 1, 0, that is 3. Okay, and we have 1, 0, 0, that is 1. Okay, so playfield 1 is color 3, playfield 2 is color 1. When they collide, we have a red screen. The background color, we are changing it here, register 180. And here he's giving us, we can change it. You can see the difference between this one. So it's 0, 1, 0, so which is 2, and it is 1, 0, 0, which is 1. So 2 and 1, collisions between 2 and 1, he's saying here. So let's try it out. Two and 1. There you go. 2 with 1. Playfield 1, number 2, and playfield 2, number 1. As you can see, the orange and the, I don't know, blue or sort of blue, when they collide, we have a collision detection there. Let's see. To be honest, I should have switched to the Amiga to see it better. So you can see color 2 in playfield 1 with color 1 in playfield 2. Okay, I'm going to leave it and I switch to the book. Because I think there's another example coming in. Yeah. And this time we are detecting color 1 on both playfields. However, this one, I think I better show it to you before I even explain it, because I think I'm going to confuse you. Okay, let's go to the Amiga and do it. So, can you guess which colors are colliding? It's 3 and 1, boom, 3 and 3, and 1 and 1. So all odd are colliding. So I'm going to bring the book back and I leave it running there. you can see we have 1, 0, 0, and we have 1, 0, 0. So we set color number 1 for both playfields, but for both dual playfields, but we have enabled this one and disabled that one. So whenever these are the same, okay, because we don't care about that one, they are colliding. So he's saying we have active 679 for what he's referring, 679. I think he's referring to the colors, but in the high order. Forgot. Yes. So, as per my notes, hence color 1 and number 3, okay, are colliding, but vice versa. I mean, anything which is odd is colliding that there. He says the value of bit plane 3 has no importance because we actually switched it off. So it doesn't matter to us. So I just should have read this sentence, not try to understand, not try to decode those up there. As I said, color 1, it starts from here actually. Color 1 of playfield 1 and color 3 of playfield 1, okay, collide with color 1 of playfield 2. So 1 and 3 collided, 1 collided. As you can see, it can also be confusing for me, let alone for you that you have seen it for the first time. It took me quite a long time to get to the grips of this. And the best way, as I said, write it down. If you try to work it out in your head, because I'm trying to teach you this, I've been trying several times to do it in my head, and every time I do it in my head, I fail. But when I look at my notes, then it clicks. So I insist that you write it down as binary and you try it out like that and learn it that way. Now, what's coming next, I will only talk about it. I'm not going to say what the book is saying, okay? But I'm just going to bring in front of me the registers. I think they are here. Yes. I'm just going to highlight these 4 registers. Oh, come on. Sometimes Acrobat doesn't let me highlight things. There you go. And I'm going to leave it like that. So we have arrived to a particular section in the book related to sprites. It's the last part. I mean, there is animation, but animation is nothing. It's not much. However, we have arrived into a section of the book that so far we've been dealing with sprites using DMA. Okay, we specify a block of data where we have the v start H start, V stop, and the special register, and then the data of the sprite, and then 0 0. And the Amiga took that data, okay, and displayed it on the screen. Like that, we are limited to only have 8 sprites, okay. And we also learned that we can have, okay, 8 sprites. We can reuse the sprites several times as long as there is a difference between the one on top and the lower one. So there's like one line of difference, okay. That is true when you use the hardware sprites of the Amiga using DMA, but there's a way of using the sprites without DMA. Now, there are some limits to it, so don't go and start saying that I'm teaching something that is out of, you know, the world. Most people think that the Amiga has got 8 sprites and then it's able to multiplex them several times down below. I'm going to tell you that is wrong thinking. The Amiga is able to do more than that. What you see scrolling on the screen, okay, is a scenario, okay, done with 2 sprites. As you notice, the first sprite and the second sprite are next to each other. It's a block of 32 by 14, okay, that's how big it is. And the same sprite, the same 2 sprites are put next to each other. The screen needs 10 sprites to be filled in, so we have 5 of each, okay. If you have 32 by 14 and you have 320, okay, you need 10 of them, okay. But then 5 of one sprite and 5 of the other. So this is something that for many of you is like a surprise, thinking that the Amiga could only do 8 sprites and then it can multiplex several times further down. The problem with this is that, first of all, not to use DMA, the data becomes very complex. There are software programs that were written to handle this because it's impossible to write it down. I will, let's say, be showing you how to create these. Not sure if I will be going into the detail of using software for this. And there are several reasons. So it depends from the book in a way. What you need to understand is that when we are using the MA, okay, imagine a postman, okay? What does the postman do? We give him the letter, he takes the letter and he posts it to another address, okay, where the letter is delivered, where we want it to go. That is what the MA is doing. It's taking what we defined and is displaying it to the screen. But what if we don't use the MA and we do it in person? We just go to the screen and do it to the screen. That is by combining these 4 registers and the copper list. And using the copper, not copper list. Copper list is what we write. So by combining the copper and these 4 registers, we're able to write to the screen several times the same sprite and on the same line. Here you're seeing it written 5 times on the same line, the same sprite. Of course, as I said, it becomes complex, but it is possible. Sometimes you see demos with bars going vertically, okay, with lots of colors, okay, vertically, okay, being horizontal, okay, and then you see vertical bars moving left and right. Normally, those are sprites. I'm not saying it's always, but it's a trick. Okay? And this is how they achieve it. The other good thing is, I don't know if you're realizing, but we have dual playfield. Okay? You can have parallax using dual playfield. Okay? One screen moving in front of the other. But we can also have the sprites moving either in front, in between, or at the back. That means we can create more than 2 layers using this technique. So the subject that I will be covering next week is it's a bit abstract, to be honest. You have to understand how the hardware is handling it. If you look at the examples, of course, you get it better. So this is why I encourage you to start looking at the examples. Please note also that after next week, when we finish the chapter of sprites, okay, from next chapter, okay, chapter 8, things will become more complex. Without the code, many times you're going to be lost. And I'm saying this not to discourage you, but the code is going to get longer and longer. We are still in this is page 98. Let's say we did 100 pages. The book has got 400 pages, but sources, okay, the book is 1,872 pages. So you can imagine that the sources are going to be longer and longer. Hence why I insist that you, okay, download the book, download the sources, and start following the book through the sources, through the book and through the sources, basically. For today, I'm going to finish here with this note that the Amiga can have more than what we thought in terms of sprites. I don't want to say infinite because it's not right, but we can have more. I wish you a good week. I will see you next week. Thank you very much. Bye bye.